Hello, ladies and gentlemen. Hopefully, you all are doing well. All right, I wanted to start off today with a quote. Be the best version of you. All right, so ladies and gentlemen, lesson 16.1, area of quadrilaterals. The state of Texas expects you all to be able to model area formulas for parallelograms, trapezoids, by decomposing and rearranging parts of these shapes. What they mean, ladies and gents, let's say, for example, if we have a parallelogram, if you were to cut off this part right here, you could rearrange it so that it fits right there. And we would have a rectangle. That's what they're trying to say, ladies and gentlemen. Alrighty, so here's the formula. Area is equal to base times the height. Please don't forget, ladies and gentlemen, your base and your height are always perpendicular. They form a 90-degree angle. That's perpendicular right there, and that's the 90-degree angle there, okay? That's crucial. Alrighty, so which brings us, and this is what you guys are going to have access to on future assessments. You will have your reference sheet, which will be one of your best resources to utilize. Alrighty, so find the area of the parallelogram. I'd like for you all to go ahead and find the area of this parallelogram. We know it's a parallelogram. The formula is area equals base times height. Here, if we break it apart here, area equals to, base equals to, height equals to. We don't know the area, that's what they're asking us for. However, we do know the base, which is 14, and we also do know the height, which is 7. We have everything we need, so now we substitute that into the formula. And we establish that the area is 98 centimeters squared. Since we're working with area, it is squared, ladies and gentlemen. Alrighty, next we're going to be working with the area of a trapezoid. The area of a trapezoid, it's half its height multiplied by the sum of the length of its two bases. This right here, it's going to be different from what y'all see in your books or the PDF versions that I'm attaching. But what I did here, I snipped it from your reference sheet and I just plugged it in there, okay? Because that's what they're both the same thing. Honestly, both of the formulas are the same. It's just that since this is how you guys are going to see it on your reference sheet, that's why I'm going with this format. All right. Remember, your bases, your base 1 and base 2 are always parallel, ladies and gentlemen. Always, always, always. They're always parallel, okay? They're opposite of each other, so to say. Think of railroad tracks. Alrighty. So I'd like for you all to go ahead and solve for the area of this trapezoid here. And please make sure you guys always write the formula down and you guys break it apart. That helps me identify, if there was an error, it helps me identify where the error was. All right, ladies and gentlemen. So y'all should have had 448. Our units are feet. We're working with area, so it's feet squared. Alrighty. So ladies and gents, this is what I'm going to be looking for. Because when you guys show me the formula like this, okay, that helps me identify or rule out that possibility of 1,000 error. Because some of you also struggle with your shapes, which is understandable. Then when you guys break it apart here, it helps me identify that you all did plug in the right values, that you guys did use the right ones. Because in this case, they could have given you another side length here. They could have added, let's say, for example, they could have told you guys this was, let's say, 20. And that would have been irrelevant for at least for the area. We wouldn't need to know that. That's completely irrelevant. And the state of Texas expects you all to identify what information is pertinent for you all to solve for what they're asking for. But anyways, ladies and gents, and here, let me take that off. Well, guys, when you guys substitute those values there, my suggestion, although either way would work, you guys can multiply 56 times 16 and then multiply times 0.5 or divide it by 2, same thing. Or you guys could get the largest even number and divide it by 2 and then multiply times the other number. That's just my suggestion. All right, and there's the example that we just went over. All right, I'd like for you all to please go ahead and solve for the area of both of those figures, please. All right, you all should have had 117 inches squared for that parallelogram, and you guys should have had 168 centimeters squared for the trapezoid. All righty. All right, so now, ladies and gents, a triangle utilizes a formula, please, ladies and gents. I cannot tell you guys The most common mistake here is just you guys forget to divide by 2 or to multiply times 0.5. They're the same thing. So once again, please don't forget your base and your height are always perpendicular. They form a 90-degree angle. So here we have a triangle. The formula is area equals 1/2 base times height. Area equals to base equals to height equals to. Here, ladies and gentlemen, they're asking us for the area, so let's put a question mark there. The base here is 20. The height is 8 meters. So now we have all that we need. Let's substitute those values into the formula. Area is equal to 1/2 of 20 times 8. Once again, my suggestion is to half the largest even number, which is 10, times 8, which is 80. All right, so the area of this triangle is 80 meters squared. Okay. All right, so next was solving area equations, lesson 16 and 3/10, or lesson 16.3. The state of Texas expects you all to be able to write equation. Go back here. To write equations that represent. Write equations that represent problems related to the area of rectangles, parallelograms, trapezoids, and triangles, where dimensions are positive rational numbers. So this is kind of working backwards, so to say. Here, they're telling us that Renee is sewing a quilt whose pattern contains right triangles. So we know the triangles. Each quilt piece has a height of 6 inches and an area of 24 inches squared. How long is the base of each quilt piece? All right, so they gave us a lot of information. Here, we know that we're working with triangles. So utilizing your reference sheet, we identify the formula for the area, which is 1/2 base times the height. Let's break it apart. And this is why I ask you how to break it apart, because it makes it easier to identify and just substitute those values in there. So height. Here, they tell us the area is 24 inches squared. So I'm going to plug in 24 there. They're asking us for the base. We don't know what the base is, so let's put a question mark there. And they do tell us the height, which is 6 inches. So now we have everything. Let's go ahead and substitute those values into the formula. Instead of the area, let's substitute that with 12 is equal to 1/2 of the base times the height, which is 6. Half of 6 is 3, so I'm going to rewrite this as 3 times the base is equal to 24. Well, remember, 3b means 3 times b. What is the opposite of multiplying the base by 3? Divided by 3. What I do to one side of my equal sign, I do to both sides. And ladies and gentlemen, we established that the base is 8. And if you guys aren't sure, you guys can always double check. Plug it in to the formula. So the base is 8. The height is 6. So what I mean by that is this here. Area equals 1/2 base times height. So 1/2 area is equal to 1/2 of 8 times, 8 times 6. Half of 8 is 4 times 6 is 24 inches squared, which is right there. Okay, double check your answers. Alrighty. Next, we're working with a different question here. All right, they're telling us that, let me get my highlighter, okay. The cross-section of a water bin is shaped like a trapezoid. The bases of the trapezoid are 18 feet and 8 feet long. It has an area of 52 square feet. What is the height of the cross-section? All right, so right now we know we're working with a trapezoid. So I'd like for you guys to go ahead and solve it. All right, and this is what y'all should have, ladies and gentlemen, 4 feet. Makes it a lot easier when you guys break apart the formula, huh? All right, so which brings us to our new lesson here. Lesson 16 and 4/10, 16.4. Solving volume equations. All right, so write equations that represent problems related to the volume of right rectangular prisms where dimensions are positive rational numbers. All right, so let's see. Problem solving by finding volume. All right, so to find the volume of a box, which is in the shape of a rectangular prism, you can multiply the length times the width times the height. The volume of a three-dimensional shape is always in cubic units, such as cubic meters or cubic inches. What that means, ladies and gentlemen, is the following. Because when we're referring to volume, volume is how much space something occupies. So we use three-dimensional figures or units, which I'm showing in this little model down here. Y'all can see right there. Whenever you're trying to find the volume of something, it's like how much space or how much can something hold. Okay, so here we go. Okay. And you guys do have this on your reference sheet. You'll have the formula for the volume of a rectangular prism is volume is equal to the area of the base times the height. That uppercase B doesn't just represent base. It represents the area of the base, which you find it by multiplying if you guys look right here, let me change this to red. Your length times your width, which is the area of the base. Same thing, okay? All right, so moving on. Example number 1. A rectangular swimming pool is 25 meters long and 17.5 meters wide. It has an average depth of 1.5 meters. What is the volume of the pool? All right, so here we have everything, ladies and gentlemen. Here they identified the length, the width, and the height. So you guys kind of just multiply them. Let me solve this using this formula here. So the volume we know is equal to the area of the base times the height. I'm going to deconstruct it here because sometimes we're going to have to work backwards. The area of the base is equal to, the height is equal to. Here, I'm going to ask that you all draw out the base because that helps us identify the values faster. The base is whatever it is situated on, unless they tell you different. Sometimes they'll tell you, okay, you know what, the sides, the shaded regions are the bases or something like that, but they'll tell you, they'll always identify what the bases are. So here the dimensions or the measurements of the base is 17 and 1/2 by 25 feet, or 25 meters, I'm sorry. So here, to find the area of the base, we would multiply the length times the width, which is 25 times 17.5. Okay, which equals to 437 and 1/2, or you guys could leave it as, you guys could convert it into decimals. But more than likely, if they give you guys fractions, your answers are also going to be in fractions. If they give you guys decimals, more than likely your answers are going to be in decimals. I can't say it will always be the case, but more than likely. And we know the height is 1 and 1/2. So I have all the values. I'm going to substitute them into the formula. So 437 and 1/2 multiplied by 1 and 1/2. And when you guys multiply all the values, you all end up establishing that the volume of that swimming pool is 656 and 1/4 cubic meters, which can also be expressed with the exponent 3 meters cubed. Okay. All right. But when you guys are solving these types of questions, ladies and gentlemen, I am going to ask that you all deconstruct the formula. If you guys are going to use volume equals length times width times height, then, break it apart, identify each of those values that they've given you. And also, I'm going to ask that you also draw out the base and label or place the dimensions. That helps me identify any errors if there are any. Alrighty, I'd like for you guys to go ahead and try number 1 on your own, please. All right, ladies and gentlemen, y'all should have had 925 inches cubed. So in this case, ladies and gents, I drew it out because it makes it easier. I mean, I think because a lot of us are visual learners, so I do find it easier when we draw it out. Oh, and I'm sorry, I did forget one step. I forgot to draw out the base there. Let me label the dimensions here. So it's 18 and 1/2 by 12 and 1/2. Yeah, so this is what I'm going to be looking for, okay? Because this helps me identify where the misunderstandings were, if there were any. Alrighty. All right, so next, writing equations using the volume of a rectangular prism. Oh, time is up.